Now, in this class, we'll be learning about the, if you remember, we had HCP, okay, and after that we had upward triangle, then we had downward triangle, and after that we laid atoms here. We got tetrahedral voids of layer A, and we also got a new layer, that is tetrahedral voids of layer B. After that we had this was converted into octahedral voids. Then when we put atoms on this, it was not useful. When I put atoms on octahedral void, I got ABC, 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 ABC type. If I put atoms on tetrahedral voids made by B, I got AB, AB type of structure, right? AB, AB type of structure. So let me just erase these parts. And so now I'm going to make the hexagonal, that is AB, AB type. Sorry, this is AB, AB type in 3D. And this AB, AB type, if you remember, in SCP also we have AB, AB type, in HCP also we have AB, AB type. And so in SCP we had, so in that the base layer was square close packing, and this AB, AB type will have a hexagonal close packing structure as the base layer. As the base layer will have hexagonal close packing. Fine. So let me take a few atoms, and I will show you guys the unit cell also that I'm going to make. Okay. As you can see, I have made hexagonal close packing. Okay. And in this, I will be covering some of the voids. I will be covering some of the voids. So the voids that I will be covering are, wait a second. This needs to be adjusted a bit. So I'll be covering this upward facing voids. And this will require 3 atoms. So let me get 3 atoms. As the 3 atoms are in here. Okay. I have kept 3 atoms here. Okay. And just on top of it also, I will add, just on top of it, I will add the 6 black atoms again. Okay. So, sorry. So this is the A layer. This is my B layer. Okay. And on top of it, I'm adding again the A layer. All of you got this? Yes or no? Please tell me. The atoms that I'm taking for the making of unit cell. Got this? Yes or no? हाँ guys, जल्दी बताइए.
This is in 3D, right?
This is all in 3D. This is all in 3D.
Yeah, okay.
Okay, fine. So we have got this one layer. Okay. And then we have got this 2 layers, right? In this, I need to delete the atoms. इसके ऊपर जो layer था वो कौन सा था? आपका red वाला atoms का था. So let me place this here. And then again, on top, I will be having those A layer atoms. Size को थोड़ा छोटा कर देते हैं. These atoms will be here. Okay, so here we have this as the A layer, this as the B layer, and this again as the A layer. Fine. Now I will take the midpoints of these atoms and make the unit cell. Okay, I'll make the shape of unit cell, whatever it is going to come. I have an atom here, and there are 2 atoms in the back. There is 1 atom in the front here. There's 1 atom in the front here. Then we have an atom here. In the middle also we have an atom. So this is the upper layer, the A upper layer as we have got. Similarly, I have a same type of layer below also. This is again upper, the A layer. And between these two layers, I will be having the 3 red atoms that I will make them later. Okay. So let me join these lines. After it, we have 3 red atoms here, here, and here. So as you can see, these 3 red atoms are completely inside the unit cell. Okay? And we have the atoms which are in the corners of the hexagonal base of this unit cell. Right? So the base of this unit cell is hexagonal. Okay, and it is 3D as you can see. Right? So what will be the, so this is a hexagonal unit cell. And this packing is known as hexagonal closed packing in 3D. Hexagonal closed packing in 3D. So this is HCP in 3D. Now, the first thing that we are going to calculate in this is the first thing that we are going to calculate is the Z. Okay, the number of atoms. So first thing is calculation of Z. Calculation of Z. Z is the number of atoms. Calculation of Z. So in calculation of Z, we have to look at first of all how many types of atoms are there with respect to the position. So you can see there are corner atoms. Okay, there are atoms which are inside, and then you also have these atoms
Face
which are in the
atom.
face center. Sorry.
Face
Yes,
atom.
Fatima. Face center atoms. Correct. Face center atoms. Face center. Okay. So now you have corner, inside, and face center. Now the how many are in corners? Tell me. How many are there in corners?
9.
9, not 9. See, these red ones are not in corners. Okay, so these are completely inside. अगर आपको ध्यान हो, आपको दिख रहा है ना, ये जो है यहाँ पे है. So these are 12. अच्छा, अब ये बताइए, what do you think? What will be the contribution? Corner का. Tell me. What do you think will be the contribution of the corner atoms?
1/8.
1/8, as you remember from the solid state, that is sorry, the cube structure, but it is not going to be 1/8, and the first reason is that because it is hexagonal unit cell, and for here also what we need to do, we need to look at the corner atom and let us see how many rooms it is shared by. So I will make, if you look at this corner atom, so let me color it with some different color. If you look at this corner atom, then this will be shared in 3 rooms in the same floor. Right, I can make unit cells like this, more unit cell है ना ऐसे दिख रहा है आप लोगों को, right or not? All of you can see ना?
Yes, sir.
Okay, fine. So here we can make in the same room, sorry, in the same floor, we'll have 3 more rooms in which this atom will be present, and similarly there will be a room above this room, above this room, and above this room. So in total, this atom, a corner atom, is shared by 6 rooms, right? Can all of you see that? It is shared by 6 rooms. Yes or no? Please tell me fast now. Right? Fatima, कोई दिक्कत यहाँ पे?
नहीं, sir.
Okay, fine. So corner atoms are 12 and its contribution is how much? 1 by 6. So this will be equal to 2. The inside atoms are 3, the red ones. So their all the contribution is 1. That means they are present in only one room, and hence it will be 3 again. And the face center atoms, so there are 2 face center atoms, and as you can see, it will be shared by one room in the above floor, and this atom will be shared by one room that is in the down floor. So each of these face center atoms are shared by 2 rooms, and this will be equal to 1. So if I look at Z, then this is equal to 6. जी बताइए.
जो फेस सेंटर एटम्स है, that one is also in the up one and also in the down one, right?
हाँ, ये एक ना. This atom is present in 2 rooms.
Up, yeah, 2
Up,
room.
this one, हाँ, ये रूम में है और ये इस रूम में तो है ही, है ना?
Yeah.
So contribution will be half.
How?
कितने रूम में प्रेजेंट है बताइए?
एक एटम 2 रूम्स में है.
एक एटम 2 रूम में. तो एक रूम में कितना एटम प्रेजेंट है?
1/2.
तो कंट्रीब्यूशन 1/2 होगा ना?
हाँ.
आ गया?
Yes, sir.
Okay, fine. So Z will be equal to 6, right? All of you can see that, yes or no?
Yes.
Okay. Second is coordination number. Second is coordination number. So for coordination number, I want to look all of you to look at this atom here. This black atom. दिख रहा है आप लोग? Yes or no?
Yes, sir.
Okay, fine. So it is touching how many atoms?
6.
6 atoms, right? In the same layer. In the same layer, it is touching 6 atoms. And also, you know that these 3 atoms will be like this in the packing, correct? ऐसे होंगे, है ना? So these 3 atoms are also touching the black atom, the highlighted black atom, correct?
Yes, sir.
Yes.
Yes or no? Okay. Similarly, A layer is there, then you have B layer, then you have A layer, then again there will be a B layer in which there will be 3 red atoms, correct? Yes or no?
Yes.
Yes.
है ना? And these 3 red atoms will also be touching the highlighted black atom, correct?
Yes.
सही है?
Yes, sir.
कितने हो गए? कितने हो गए?
12.
We have very good coordination number. It is equal to 12. So here we have 6 in the same layer, 3 from above and 3 from below. 3 from below. Now, next thing that we always learn is the relationship between A and R. And if you remember, the cause of learning relationship between A and R is because of the packing efficiency. So in packing efficiency, we have to eliminate this R and A, and that is why we study the relationship. But right now, as you can see, we don't have a cubic structure. So in this hexagon, the cell dimensions, that means what are the edges, length of edges that we have. So you can define that there will be a length defined as A. There will be a breadth you can define as B. Okay, and there will be a height that you can define as C. Right now, this hexagonal unit cell. So third thing is the cell dimensions. Cell dimensions. So since it is a 3D object, so it will have 3 dimensions, that is A, there will be B, and there will be C. So we have got ABC length, right? ABC length, and there will be angles corresponding to these sides also. So there will be alpha angle, there will be beta angle, okay? Alpha angle, beta angle, and there will be gamma angle. Now please see what is this alpha angle. So the alpha angle, you can see alpha and A. So you remove A, and alpha is the angle between B and C. Okay, so this is how in maths we define things: alpha, beta, and gamma. Beta is the angle between A and C. Okay, beta is the angle between A and C, and gamma is the angle between A and B. Will that be clear for all of you? Please tell me yes or no about the cell dimensions. बताइए, हाँ या ना?
Sir,
Yes.
जी जी बोलिए.
the width
हाँ,
is,
tell.
where is the width?
ये है ना B.
किधर है?
This guy. Okay. So you can say that it can be same also, right? Here it is same only, but again, whenever you have a 3D object, there will always be a length, breadth, and height, right? Length,
Yes.
width, and height will always be there. And even though length and width or any two things can be same, any three things can also be same, but again, they will always have a length, a width, and a height. Thing. So now the next thing
So
is that
A and B will have the same length.
here it will be same only. Okay, here it will be same only. As you can see, क्या है A and B? So sorry, A and B is this distance. ना यहाँ पे देखिए आप, ये distance आपका A है, ये distance आपका B है, दोनों तो 2r है ना? Can you
Yes.
see that? है ना?
Yes,
So here
sir.
it is same, but again there is length. Why I'm saying A, B, and C? Because if you have a 3D object, you will have a length, width, and length, width, and there will be height also. So here A and B they will be equal, and B and this will be not equal to A and B, right? C will not be equal to A and B, right? Now let us talk about the angles here. Let us talk about the angles here. Okay, now just imagine yourself in a hexagonal unit cell room. So this will be one of the edges of wall, right? Yes or no? Sahi?
Yes, sir.
Right? See. Okay. And this will be in edge of the floor, correct? Sahi hai? Floor ka. Hai na?
Yeah.
Now, both of these will be 90 degree. Right? Yes or no? If I talk the angle between
Yes.
A and C or A and B. Okay. So the angle between A and C, that is A and C का angle कौन सा है? Beta, and B and C का angle कौन सा है? Alpha. So we can say that alpha and beta, these are equal, and this is equal to 90 degree. This is equal to 90 degree. And you know this is a hexagon, right? And we have already discussed the angle between A and B. That means the angle between hexagon, the sides of hexagon will be equal to 120 degree. And you can write gamma here, it is equal to 120 degree. Is that clear? Yes or no? Please tell me about alpha, beta, gamma, A, B, C.
Sir, gamma 120 कैसे हुआ?
हेक्सागन में क्या होता है? रेगुलर हेक्सागन अगर होगा तो व्हाट विल बी द एंगल? एचसीपी में पढ़ा था ना हमने, 120 डिग्री है. क्या होगा इसका एंगल बताइए? रेगुलर हेक्सागन का एंगल कितना होगा? यू अंडरस्टैंड व्हाट इज अ रेगुलर हेक्सागन, फातिमा? ये सानू
Yes, sir.
है ना? ठीक है, तो इट विल बी 120 डिग्री. ओके, रेगुलर हेक्सागन विल बी 120 डिग्री.
पूरा like all of the angles.
ऑल ऑफ द एंगल्स, हाँ, ऑल ऑफ द एंगल्स विल बी 120 डिग्री. करेक्ट. ठीक है. व्हाई आर यू सरप्राइज्ड विद दिस? हाँ, ये नया इंफॉर्मेशन आपके लिए हेक्सागन के बारे में. जी फातिमा?
9.
नहीं ना? Okay. Fourth is the packing efficiency. So in this case, you don't have to worry about the packing efficiency, how to derive it, okay? Because in this case, you will have to find the relationship between A and R also and C and R also. Why? Because if you look at the volume, so volume is what? If you remember some 10th standard, then you know that volume is equal to area of base of any 3D object into its height. Yes or no? For example, cylinder याद कीजिए आप. So what is the volume of cylinder? Tell me. What is the volume of cylinder? Volume of cylinder, guys. किसी को नहीं याद?
Pi r square h.
Very good. ठीक है. Pi r square h. आपको दिख रहा है? Pi r square क्या है? बेस का एरिया, सर्कल का एरिया, सही है ना?
Yes, sir.
Into height. Okay, so volume of any 3D object is the area of base into height. And if you remember the area of base of a hexagon, it is what? It is 6 into root 3 by 4 a square. A is the edge length into, I can do C here because C is the height that we have taken. So this is the volume. And as you can see, we have A term here and C term here also. And in the numerator, we'll be having R term. So we need to have a relationship between A, C, and R. That is why this is not there in your syllabus. Okay. Don't have to derive the relationship between packing efficiency, but you need to remember the packing efficiency of hexagonal close packing, which is equal to, similar to face center, it is 74%. Okay, this is also equal to 74%. Is this clear? Yes or no? Please tell me. जी बताइए जल्दी. सही है? Write the next point, that is voids.
Sir, we didn't write that only.
हाँ ठीक है, मत लिखिए अभी, रुक जाइए. Voids in hexagonal close packing unit cell. Okay, so I am talking about the unit cell and now talking about the packing. Whole packing की बात नहीं हो रही, unit cell. So number of octahedral void will be equal to n, and n is equal to 6 here, right? Number of atoms in the unit cell. Please remember, again I'm talking about the unit cell. then we have tetrahedral y, which will be equal to 2n, and hence this will be equal to 12. Okay, now you can write. टॉपिक लिखा आपने एबी टाइप एचसीपी 3D सब लिख लीजिए।
नहीं,
लिखिए जल्दी लिखिए। तो हफ्सा एंड सारा, आप लोग थोड़ा लेट ज्वाइन किए थे, भूल गए थे क्या क्लास के बारे में? यस सारा जी,
याद था।
याद था अच्छा। व्हाट अबाउट यू हफ्सा? यस हफ्सा,
Yes, sir.
डिड यू फॉरगेट अबाउट द क्लास?
No, I got up late. I was sleeping.
अच्छा, नींद की दिक्कत हो रही है। फिर आप लोगों का क्या हाल होगा साक रातों में? हाँ फातिमा, हफ्सा, सारा, यू विल बी वेकिंग अप ना द ऑड नाइट्स या नहीं?
I have to.
यू हैव टू। देन व्हाट विल हैपन? फिर आप क्लास नहीं कीजिएगा या स्कूल नहीं जाइएगा?
स्कूल भी जाना जरूरी है।
स्कूल भी जाना जरूरी है और क्लास,
ट्यूशन भी करना जरूरी है।
अच्छा फिर आपको नींद भी जरूरी है।
एग्जैक्टली।
फिर कैसे होगा?
अल्लाह
और पढ़ाई
will help.
पढ़ाई और पढ़ाई भी जरूरी
वो भी
है।
जरूरी है।
हाँ तो थोड़ा ना रात में ना ऑड नाइट में आप पढ़ाई ही कर लीजिएगा, है ना? अभी तो पढ़ाई भी इबादत है नहीं? हाँ
सर दैट इज डिफरेंट टाइप ऑफ इबादत।
हाँ बट स्टिल थोड़ा पढ़ लीजिएगा, मेरा रिवाइज कर लीजिएगा प्लीज आप, ठीक है?
जी सर।
जी थैंक यू वेरी मच। You must be hearing this one hadith very often. Innamal a'malu binniyat, right?
या
Let me know when you are done, guys. Okay. अरे पटना में गर्मी बहुत है क्या?
है लेकिन आज तो नहीं था।
आज तो Did it rain? दिल्ली में कहीं पे बारिश हुई थी शायद। Did it rain in पटना? No ना। जल्दी लिखिए।
हो गया।
Yeah, Hafsa is also done. Sarah, waiting for you.
Done so.
Done. Okay, fine. So since we have done most of the things, let me write one question similar to what we did in FCC also. Okay. So my question is, solid forms a solid form HCP lattice. ठीक है, लैटिस मतलब सॉलिड का जो स्ट्रक्चर है HCP लैटिस है ना. What will be the number of octahedral voids and tetrahedral voids in 2 moles of it. ठीक है, कीजिए इसको, बताइए कितना होगा. ये बताइए नंबर ऑफ एटम्स कितने हो जाएंगे पहले, ठीक है ना. फर्स्ट ऑफ ऑल यू गाइस विल टेल मी इन दी chat what is the total number of atoms.
Two into 6.022 into 10⁻23.
ये आपको याद नहीं है क्या? 10 to the power 23 एवोगाड्रोस नंबर नहीं याद आपको? फातिमा बैठ के रटिए इसको. ओके फातिमा
जी सर.
जी, अच्छा. So octahedral void is how much? Is equal to n, right?
Yes
कितना हो
sir.
जाएगा n? So what will be n? It will be the
6.
same है. हाँ, ये नंबर ऑफ एटम्स ये है पूरा, ठीक है. तो इट विल बी 2 into 6 है ना. ध्यान दीजिए, ध्यान. 23. टेट्राहेड्रल voids कितने हो जाएंगे? 2n, which will be equal to 2 into what is n? 2 into 6.022 into 10 to the power 23. चलिए जल्दी इसको लिखिए. Then we will revise everything that we have done till now. कौन सा क्लास है आपका? 1 2 3 4 5 क्लास है. I think fine, we are on time. ज़्यादा लेट नहीं हुआ. Done ना all of you? आगे बढ़े.
Yes.
So we started with 1D packing. In 1D packing, we had only one question that can come, that is the coordination number of atom, which is equal to 2. Then we went and we studied about, don't write anything. We studied about the, tell me what, after 1D packing, what did we study?
2D
1D packing के बाद 2D packing, ठीक है. 2D packing, ठीक है. 2D packing के से पहले एक चीज हम लोग को याद रखना है. So I'm writing each and everything that is has to be remembered. So you have to remember face center. Sorry, number पहले faces. There are 6 faces and each of its contribution is half. Then there are corners which are 8. Each of its contribution is 1 by 8. Then you have edges, and how many edges are there? 12. Each of its contribution is 1 by 4. Then the thing that you have to remember is phase diagonal, which is equal to a root 2. Then you have to remember body diagonal, which is equal to a root 3. Okay, so these are the information that you also need to remember. In 2D packing, we saw that there are 2 types. We can have, there are 2 types. We can have 2 types here. We can have square close packing. This is in 2D. We can also have hexagonal close packing in 2D. Things that you need to remember for SCP and HCP are many, but important things that are the packing efficiency. Packing efficiency of SCP is how much? 52.4%. For HCP in 2D, the packing efficiency is 90.6%. Okay. Now moving on, from SCP we saw that we can make 2 different type of 3D unit cell. Okay. हम कहाँ जा रहे हैं? SCP से 3D. Now in 3D we saw that we can have simple cubic and we can also have BCC structure. We can also have BCC structure. Now from SCP, if I go to 3D, I saw that I can make 2. One is the HCP, hexagonal close packing. This is in 3D. And we can also make FCC. And the unit cell of FCC is CCP. So I'm also writing CCP here. Now for all of these, I will write, we have to remember a few things that I will be writing here. ठीक है, तो पहले कुछ लाइन बना लेते हैं. So please write this down till यहाँ तक, है ना, जब तक हम लाइंस बना रहे हैं. So we will be discussing here the Z for each of them. Okay. Then we'll also discuss the coordination number, let us say. Then the relationship between A and R. Then the packing efficiency. Okay. And then we'll discuss the type of voids that is present. Okay, in all of them. Then ठीक है, लिख लिया आप लोगों ने यहाँ तक?
नहीं.
जल्दी कीजिए. And try not to look here, or you already know what are these things, right? 1D packing, 2D packing, तो अपने ही आप दिमाग से बनाने की कोशिश कीजिए, ठीक है? Nothing is new here. एक एक वर्ड छाप के मत लिखिए. 1D, then you packing, PAC. Don't do that. Try to remember things and write on your own. कितना ज्यादा से ज्यादा हो सके रिटेन करने की कोशिश कीजिए. रिटेन. बच्चे क्या गलती करते हैं? they try to memorize a lot of things. They only read, only input. Input means they are doing classes, they are going to school, then they are self-studying. Self-studying में भी क्या कर रहे हैं? No, they are reading notes, है ना? So there is a lot of input. ऐसा लगता है जैसे एग्जाम में इसी चीज का कंपटीशन हो, कौन कितनी देर पढ़ सकता है, कौन कितनी ज्यादा पेजेस पढ़ सकता है. बट नो, in exams you have to give output. So try to retain as much as possible. Okay, so even when the teacher is speaking, when the teacher is writing some things, I said not outwardly, but also try to second guess the teacher what he is going to speak next. ठीक है, ये सारी चीजें थोड़ा लाइक बहुत छोटी छोटी चीजें जो आपको बहुत मदद करेंगी केमिस्ट्री को याद रखने में, है ना? एंड दैट विल हेल्प यू इन एग्जामिनेशन. ट्राई टू डू क्वेश्चंस, असाइनमेंट्स अब ज्यादा ध्यान दीजिए करने के लिए, ठीक है? इसी वजह से रिवीजन के लिए तो हमने कितना छोटा बढ़ाया बताया आपको. 5 मिनट पहले, 5 मिनट बाद, है ना? और 5-10 मिनट आपको टॉपिक्स रीड करने हैं बस, नथिंग एल्स आफ्टर दैट. बट यू हैव टू डू असाइनमेंट्स, वो भी नहीं मिलता हमको. हो गया? बढ़े आगे?
Yes.
Yes, sir.
ओके फाइन. चलिए अब आप लोग यू हैव योर नोटबुक, ठीक है ना? यही इंपॉर्टेंस है नोटबुक का. अभी हम जेड पूछेंगे सिंपल क्यूबिक का. आप नोटबुक में देख के बताइए कितना है, या फिर अगर आपको याद है तो बताइए, है ना? ऑल ऑफ यू, ओके प्लीज. हफ्सा, फातिमा बात करती हैं. हफ्सा, you please also turn the mic on, and Sara, you also, okay? चलिए, simple cubic, what is the Z for simple cubic? What is the Z for simple cubic? Simple cubic के लिए क्या है Z?
1 sir.
1. हमको बहुत कुछ सुनने को मिला, 2, 4 भी सुनने को मिल रहा था. I don't know how. What is the coordination number for simple cubic? Coordination number for simple cubic. अरे देख के बताइए, जल्दी बताइए, जल्दी. क्या हो गया?
6.
फातिमा एंड सारा. फातिमा,
8.
यार एक तो ना हम जूम के अंदर घुस के आप लोग को मारेंगे. आप लोग नोटबुक देख के बताइए ना कितना कोऑर्डिनेशन नंबर. नोटबुक देख के बताइए कितना कोऑर्डिनेशन नंबर सिंपल क्यूबिक का. फातिमा, यू आर राइटिंग नोट्स ना? हाँ,
Yes.
अलग अलग कॉपीज में लिख रही हैं क्या आप? जी फातिमा,
No, sir.
तो फिर क्यों नहीं मिल रहा आपको? कहाँ पे सिंपल क्यूबिक? कोऑर्डिनेशन नंबर 6. रिलेशनशिप बिटवीन ए एंड आर. फातिमा बताएंगी. फातिमा, टेल मी रिलेशनशिप बिटवीन ए एंड आर इन सिंपल क्यूबिक. देख के बताइए कॉपी में.
A√3 equals 4R.
वेरी गुड. A√3 is equal to 4R. सिंपल क्यूबिक देख के टॉपिक क्या पढ़िए, तो जो भी आप पढ़ रही हैं उसका टॉपिक क्या है?
Body
सिंपल
centered
क्यूबिक.
cubic.
तो सिंपल क्यूबिक बोल रहे हैं ना हम. जी व्हाट हैपेंड? हाँ फातिमा, ऐसे कैसे चलेगा? बताइए सिंपल क्यूबिक का क्या होगा?
A equals
रिलेशनशिप
2R.
हाँ, अब ध्यान से बताइएगा. बिल्कुल सही है. पैकिंग एफिशिएंसी बताइए सिंपल क्यूबिक का.
52.4%.
ये यहाँ पे हमने गलती कर दिया. दिस इज हाउ मच? तो 78.5 था ना? 78.5 स्क्वायर क्लोज पैकिंग का. ओके, दिस इज 52.4%. void is cubical void. ठीक है, BCC में Z, Fatima, Hafsa, Sara. All of you tell me what is the Z for BCC? Jaldi. What is the Z for BCC? What is the Z for BCC?
तो ये पार्ट का मेरे पास नोट्स नहीं है।
ठीक है, आगे बाकी बताएं। 2. What is the coordination number for BCC?
8.
8. Relationship between A and R?
A root 3 equals 4R.
A root 3 is equal to 4R. हफ्सा नहीं बात कर रही बिल्कुल। पैकिंग एफिशिएंसी कितना होगा इसका? What will be its packing efficiency? 68%. And the type of whites you don't have to remember. It is distorted octahedral, but still you don't have to remember. It's not there in your syllabus. Okay. HCP में आ जाइए, बताइए। HCP में what is the Z? आज तो लिखा है ना आपने सारा। All of you tell me what is the Z for HCP in 3D? What is the Z?
4.
कौन बोला 4? हफ्सा ने कहा ना, हफ्सा।
6
जी हफ्सा कितना होगा?
6.
6 ना, हड़बड़ी नहीं। हेक्स मतलब 6, हेक्सागोनल 6 हो जाएगा। ठीक है। कोऑर्डिनेशन नंबर वी हैव सीन इट इज 12। ना रिलेशनशिप बिटवीन ए और ये आपको नहीं चाहिए यहाँ पे। पैकिंग एफिशिएंसी 74%। and the void is how much we have in this particular unit cell. Okay, in HCP के unit cell what will be the voids? So we will have 6 octahedral voids and 12 tetrahedral voids. ठीक है। Now for FCC what is the Z? FCC के लिए Z क्या होगा? What is the Z for FCC? Face centered cubic? 4. Coordination number? 12. Relationship between A and R?
A root 2 equals 4R.
A root 2 is equal to 4R. Very good. Packing efficiency is?
74%.
74%.
Very good. 74%. And void is how much? We have 4 octahedral voids and we have 8 tetrahedral voids. चलिए छापिए, जल्दी छापिए। अच्छा, there is one request for you guys, ठीक है, सारा एंड हफ्सा स्पेशली, प्लीज ट्राई टू कम ऑन टाइम ना। ठीक है। एक तो इट इज 1.5 आवर क्लास, उसमें भी लाइक आई लीव फॉर 10-15 मिनट्स है ना, तो लाइक बहुत लॉस हो जाता है टाइम का। ठीक है, प्लीज ट्राई टू कम ऑन टाइम। और हमको अच्छा नहीं लगता है कि आई शुड स्टार्ट विदाउट स्टूडेंट्स। ठीक है, तो यूजुअली व्हाट हैपेंस इज आई वेट। ठीक है, बट यू गाइस ट्राई टू कम ऑन टाइम है ना, तो हम लोग के दोनों के लिए अच्छा होगा। हमसे शुरू नहीं हो पाता जल्दी क्लास इफ द स्टूडेंट्स आर नॉट देयर। ठीक है, चलिए जल्दी इसको कीजिए। लेट मी नो व्हेन यू आर डन। Sara is done. Waiting for Fatima and Hafsa. Now, whatever is present in this small slide, now this small page, small section, you have to remember each and everything from here. ठीक है, यहाँ से आपको यहाँ भी जितना कुछ है वो सब आपको याद रहना ही रहना चाहिए. You have to remember each and everything. ठीक है, and for packing efficiency, you have to also know the derivation for 3 of them, that is SC, BCC, and FCC. HCP का packing efficiency you don't have to derive, and other than that you have to remember everything. So when you are going to revise ना, आप क्या रिवाइज कीजिएगा, आप से बस इतना ही रिवाइज करना है आपको। 5 क्लास का जो भी हमने पढ़ा है अभी तक, उसका रिवीजन क्या है, उसका रिवीजन इतना ही है। एंड इफ यू रिमेंबर about the voids, so voids is very small section and you will always remember the voids. Square planar void कैसा दिखेगा, how will the triangular void look, how will the tetrahedral void look, the octahedral and the cubical. ठीक है, now this is the only thing that you will be revising from now on. This is the only thing that you will be revising from now on. I want to start a new topic, a small topic, that is nearest, the concept of nearest neighbor. Okay, so please pay attention. Concept of nearest neighbor. Concept of nearest neighbor. So for this I need a unit cell. So first of all, let me out this one. Okay, so here we have 1 unit cell. Also, I would need a few more, so I will just copy and paste them below. Now, concept of nearest neighbor. So nearest neighbor is again just like coordination number, and just like coordination number. So first thing that I will be teaching is for the simple cubic structure. Simple cubic. So if I look at simple cubic, where are the atoms? The atoms are all in corners. There are atoms which are present in the corner here. Okay. Now, all of you know that each of these corner atoms or each of these corner atoms, they are touching 6 different atoms, right? Yes or no? Please tell me. You all know this, right? Hi, Kini? No, you guys don't know
Yes.
that each of coordination number is 6, right? You know that. Okay. Now, this is the first neighbor, है? So if I talk about the neighbors, then this is the first neighbor of each of these atoms. First neighbor of each of these atoms. Now we want to look at the second neighbor, the third neighbor. So we have to look at 3 neighbors. Okay. So this structure is simple cubic. Okay. Simple cubic, and then we will talk about the number of atoms, and then we'll talk about the how many atoms are there, and after that, what is the distance of these 2 atoms. If I talk about the first nearest neighbor, so nearest neighbor, I will abbreviate as NN. Okay, so you have first nearest neighbor for simple cubic. So how many are there? Okay, so number of atoms. This will be how much? 6, and the distance between these atoms will be, what will be the distance? C. ये distance कौन सा होगा? तो ये distance होगा A. Right? This also is distance A, and this distance is also A. Right? So the distance between all of these atoms will be A. If you remember, the other atoms are here, here, and here. So these are the 6 atoms that is nearest neighbor. Yes or no? Any doubt till here? Tell me. Any doubt till here? No, no. Nearest neighbor समझ में आया? All of you tell me. Fatima.
Yes.
है ना?
Yes.
Sarah, Hafsa. Hafsa, what about you?
Yes,
Yes,
sir.
Hafsa. Okay, fine. Now, moving on, we have the next nearest neighbor. Okay, that means the second nearest neighbor. Second nearest neighbor. So second nearest neighbor, as you can see, what will be the second nearest neighbor? So we have looked at the edge length A. Now let us look at in the same level. We can see that this atom here, it is the next neighbor, right? Yes or no? आप लोग यहाँ पे गाड़ी में चलिए ना ऐसे, यहाँ से यहाँ तक आए. Then where can you go? You can go here. This can be the next neighbor. या तो ये होगा, या तो ये होगा. Correct? Yes or no?
Yes.
है ना? Now both of these are what? Phase in the phase diagonal. Both of these are in the phase diagonal. सही है, दिख रहा है आप लोगों को? Yes or no? Please tell me. All of you can see ना?
Yes,
Phase
sir.
diagonal में है. जल्दी हाँ या ना प्लीज बोल दीजिए, ठीक है ना? Now, moving on. So this will be what? First of all, the distance will be how much? We know that the distance will be A root 2. The distance is going to be A root 2. Achha. Now, how many of such atoms will be present? How many of such atoms will be present? Can somebody make a guess? How many such atoms will be present?
5.
4.
4, 5. Let us see how many atoms
Or
are present.
maybe 6.
Or maybe 6. Okay. Any other guess? Any other guess?
There are only 2.
Only 2. अच्छा,
Hmm.
नहीं देखिए, आपको ये देखना पड़ेगा ना कि दिस पर्टिकुलर कॉर्नर, ये एक कॉर्नर है, राइट? दिस कॉर्नर कैन मेक मल्टीपल फेसेस, है कि नहीं? एक कॉर्नर से आपके कितने फेस बन सकते हैं? वन कॉर्नर कैन मेक अ फेस लाइक दिस, in the same unit cell it can make how many faces? You can see 1 2 3, right? ये सारे फेस उसी के हैं? Yes or no? This corner is present na in all of these 3 faces. So now you can see that it will be touching these 3 atoms. Corner कौन सा था हमारा? This corner was there. No, this one, not this one. So this corner will be touching this atom, and this atom. ठीक है ना? तो ये 3 फेस सेंटर्स आपको नहीं, कौन सा एटम लिया था हमने? हाँ, ये एटम लिया था हमने ना. हाँ, दिस वाज द एटम दैट वी आर. एक सेकंड, ये एटम लिया था हम लोगों ने. And these are the phase center atoms that it is touching. There will be also one more phase center. Sorry, one more phase diagonal में एक और atom होगा यहाँ पे. सही है? All of you can see ना? Right?
Yes.
So एक में उसने 3 वॉल बना ली. अब देखते हैं और कितना वॉल बना सकता है ये. Now you can see I am making one more wall. Correct? कितने वॉल हो गए? 4 हो गए ना? Yes or no?
Yes, sir.
Right? There are now 4 walls. Now moving on, there are now 4 walls. अब आगे, this can make 5th wall, यहाँ 6th wall यहाँ. सही है कि नहीं?
Yes.
This can make 7th wall like this. This is the 7th wall, and this is the 8th wall. Can all of you see? Yes or no? Please tell me. दिख रहा नहीं दिख रहा आप लोग? You can you see 8 walls made by this one atom till now? नहीं.
Yes.
You
Yes,
can
sir.
see ना? Till now you can see how many 8 walls are there, right? 8 walls are there. यहाँ से देखिए एक इसका एटम यहाँ पे होगा which will be something here. Okay. Now 8 हो गए. Can you see the 9th one here? Can you see the 9th one here? Tell me. 9th one, ये वाला वॉल दिख रहा है कि नहीं दिख रहा है? बताइए. ये ध्यान रखिए आप लोग, फिर से हम बना रहे हैं, ठीक है? प्लीज बी विथ मी. फर्स्ट वॉल, पूरा वॉल नहीं बनाया हमने, ये पूरा वॉल ऐसे होगा. आई एम नॉट मेकिंग द होल वॉल, बट यू कैन अंडरस्टैंड, राइट? वन वॉल, ऑल ऑफ यू कैन सी, है ना?
Yes,
अब
sir.
देखिए, सेकेंड वॉल ये सीलिंग हो गया. दिस इज द सीलिंग, एंड देन दिस इज द लेफ्ट वॉल. ये फ्रंट वॉल, लेफ्ट वॉल एंड द सीलिंग. कैन ऑल ऑफ यू सी दैट?
Yes, sir.
3 रूम्स आर. ठीक है, ध्यान से. देन अगेन आई एम मेकिंग द सीलिंग. ठीक है, कितना हो गया? 3 4
7.
4, हाँ 4 हो गया. ये वाला हो गया आपका, ऐसे रहेगा तो 5, राइट? दिस विल बी 6. ये नहीं होगा. कैन यू सी दिस मच? This wall, this 2 walls. Yes or no? The 2
Yes.
ceilings and the 2 front walls. The 2 ceilings, the 2 front wall, and the left wall here. ठीक है? You have got 2 ceilings, right? You have got 2 ceilings, right? And then you have got 2 front walls, and then you have got this wall here that is between those 2 rooms. One in middle. ठीक है? One in the middle. Now similarly, all of these type of rooms, so you will be seeing that there will be one room. अब एक वाला आपको यहाँ पे मिलेगा ऐसे, just above, no, just above this particular wall. So now you are having what? Now you are having +1. ठीक है, +1. हम +1 ही करते जाएंगे अब. This room, sorry, this corner will also be present in these 2 rooms. सही है ना?
Yes.
तो +2 and this corner. अब ये देखिए, ये इधर वाले में भी होगा, ये नीचे वाला जो एक रूम है और ये नीचे ऊपर वाला जो एक वॉल है, ये दोनों, these 2 walls, करेक्ट? yes or no? +2 आंसर. ये तो सीलिंग हो गया, है ना? अब ये सीलिंग के ऊपर एक वॉल होगा यहाँ पे, और उसके नीचे भी एक वॉल होगा जो इस वॉल के जस्ट करस्पॉन्डिंग इधर आगे, राइट? द लेफ्ट वॉल दैट यू हैव हियर ना, दिस लेफ्ट वॉल, इससे करस्पॉन्डिंग तो यहाँ पे, तो उसका आपका हो जाएगा कितना? यहाँ पे ऊपर एक हो गया सीलिंग एंड देन यू हैव 2 and 1 आई थिंक, एक ऊपर और एक नीचे, नहीं तो 2 हो जाएगा। कैन ऑल ऑफ यू सी टिल हियर? यस और नो प्लीज टेल मी।
Yes, sir.
Can you see all of these rooms, right? So you can see how many are there, how many walls are there with this one corner, how many walls? There are 12 walls with one corner, right? Now each wall will have an atom opposite to it, an atom opposite to it. Each wall will have one atom opposite to it. This wall will also have one atom opposite to it. This wall will also have one atom opposite to it. So you can see that since it is having 12, so the total number of atoms will be 12. ठीक है, total number of atoms कितने हो जाएंगे? 12 हो जाएंगे। Got it? Yes or no? Please tell me.
Sir, I didn't understand the walls.
कहाँ तक नहीं? ऐसा तो नहीं है ना स्टार्टिंग से समझ नहीं आया है ना? ऐसा तो नहीं है? You
नहीं,
understood the
starting का समझ में आया, but like afterwards it's getting too confusing.
हाँ तो ध्यान दीजिए, ठीक है, ध्यान देने से ही आएगा और किसी चीज से नहीं आएगा। ये बताइए आप, यहाँ पे वो कितने रूम, कितने वॉल्स दिख रहे हैं? हाउ मेनी वॉल्स कैन यू सी हियर?
6 walls.
एक कॉर्नर को आप ले लीजिए यहाँ से, दिस कॉर्नर इज मेकिंग 1, राइट, दिस इज मेकिंग 2, मेकिंग 3 वॉल्स, राइट, एंड ये एक सीलिंग हो गया आपका, ये दूसरा सीलिंग हो गया आपका, है ना, एक आपका इधर राइट वाला रूम हो गया, एक आपका इधर लेफ्ट वाला रूम का, दोनों का वॉल हो गया, एंड देन यू हैव अ मिडिल वन। सो यू हैव 2 ceilings, 2 front wall and 1 middle wall between the 2 rooms। सही है यहाँ तक?
नहीं,
नहीं, क्यों नहीं, बताइए।
वो नहीं समझा।
कैन यू सी योर ओन इन योर ओन रूम? एक कॉर्नर ले लीजिए ना आप, यू कैन टेक वन ऑफ द टॉप लेफ्ट कॉर्नर, ठीक है,
हाँ,
दैट इज ऑन द सीलिंग।
यस,
बगल वाले रूम के भी सीलिंग में होगा,
हाँ,
ठीक है, और उसके बाद ये इधर के फ्रंट वॉल में, उधर वाले रूम के फ्रंट वॉल में भी होगा, राइट?
यस,
गॉट इट? तो वही तो हम बोल रहे
यस,
हैं, 2 ceilings 2 front, 2 ceilings 2 front, है ना?
हाँ सर,
Then you have the left wall, the wall which is between those 2 rooms, है ना? You have this room and
Yes,
the
sir.
adjacent room, ठीक है, तो एक मिडिल हो गया, ठीक है,
हाँ,
ओके। अब the ceiling one will have now, अब इन दोनों ही रूम जो whatever you do the 2 rooms that you have ना, उसके आगे एक 2 रूम और होंगे ऐसे, सही है, ऐसे 2 रूम और होंगे, yes or no फातिमा? In
हाँ
front
सर,
you can make 2 rooms, है ना? Then you will have again these 2 ceilings, सही
यस,
है,
हाँ,
again these 2 ceilings will be there, है ना, and then you will have this wall also, ये middle wall, इन दोनों रूम की जो बीच में middle wall है वो भी होगा नया,
यस,
है ना? So
हाँ,
that is what I am saying. Again you have got 2 ceilings and then 1 room, 1 middle, ठीक है, 2 ceilings and 1 middle। जी फातिमा, हाँ या ना? माइक ऑन रखिए ना आप, ऑफ मत कीजिए आप माइक। गॉट इट? यस और नो फातिमा?
यस सर,
जी, तो यहाँ तक आपका हो चुका है। अब आप ध्यान से देखिए, ये जो रूम है इसके ऊपर ये जो दीवार है ना आपका मिडिल वाला,
हाँ,
जस्ट अबव इट यू विल हैव वन मोर मिडिल वॉल जो ऊपर के फ्लोर में होगा,
यस,
ठीक है, उसकी तरह सेम जो आगे 2 रूम थे उसके ऊपर भी एक वॉल होगा,
यस सर,
कितने हो गए? +2,
हाँ,
ठीक है। अब ध्यान दीजिए, ये जो फ्रंट वॉल था इसके ऊपर एक फ्रंट वॉल होगा, ठीक है,
या,
एंड यहाँ जो आपके एडजेसेंट रूम है उसके ऊपर भी एक फ्रंट वॉल होगा, सही है,
हाँ,
2 फ्रंट वॉल हो गए, खत्म हो गया,
यस सर,
ठीक है। अब तो छुट्टी हो गई। You have got second nearest neighbor is 12, है ना, and the distance is a√2। The third nearest neighbor, this will be the number of atoms here, उसको हम बाद में बताएंगे। डिस्टेंस जो होगा आपका वो नेक्स्ट, अगर आप जाइएगा ना किसी में भी, तो you will see that you are going to the body, you are going to the body center now, sorry, you are going towards the body diagonal, और इसके just vertically opposite जो atom है उसकी तरफ जा रहे हैं आप। So the next nearest will be this atom here, ठीक है। For the red atom, this will be the next nearest atom. The distance of between these two will be a root 3. Okay. And now how many will it be touching and how many third nearest neighbor will be there? So you just need to know that this corner atom cell is present in 8 different unit cell, and in 8 different unit cell you will be having 8 different like opposite corner atom, like body diagonally opposite corner atom, and hence you will have 8 number of atoms. That is the third nearest. That 8 is coming from the 8 unit cell. So you can see that in 1 unit cell it is having 1 green type of atom. Similarly, if it will be present in 8 rooms, there will be 8 green atoms, and that is why you have the third nearest neighbor, which is 8, and the distance will be a root 3. Is that clear? Yes or no?
Yes, sir.
चलिए ठीक है, स्क्रीनशॉट लीजिए आप लोग, है ना. एंड आई एम गोइंग फॉर इफ्तार. आई थिंक सारा आपका भी टाइम हो गया होगा ना. सो यू गाइस कैन लाइक लीव आफ्टर राइटिंग ऑल ऑफ दिस. ओके, फाइन.
Yes.
Okay, sir.
ठीक है. हाँ, you guys can leave after this. Thank you, bye. Thank you. Bye bye. Take
Thank
care.
you, sir. Bye.
Thank you, sir.